Hi, my name is Matthew Privet, and this is my video for the C++ Programming for Games assignment. So this is my game Gravital. The original premise behind the game is using both gravity manipulation by rotating the map, and portals you use to reach the end of the map. The player could shoot portals on surfaces, but some may be out of reach. The player could then shift gravity to rotate the map around, with them ended up on separate surfaces to get a better angle at shooting the obstructed surface on the other side of the room to allow you to cross it. The new premise is still to be set inside the Portal universe, however, in this one you've mixed a portal gun and a gravity gun from both franchises to make solid projectiles which act as a gun which can incinerate anything on contact. The facility now wants you to test that weapon in this room, and it would basically just be a constant loop of killing as many enemies as possible to get as high score as you can. The enemy turrets will spawn around a play area, and after a turret is defeated, more will spawn. Defeating a turret will spawn a new one and increase the score. The original inspirations behind this game were Portal 2, Half-Life, as well as the game Little Big Planet. This was more of the portal aspect, the gravity aspect, and the general physics of how Little Big Planet works in the game world. The original genre of the game was a puzzle platformer, which is a game where you have to avoid obstacles to exit the room and complete a series of these challenges while avoiding enemies. Examples of this game is stuff like Mario Bros. And Donkey Kong. The new genre is a shoot 'em up. In this type of game, there are unlimited enemies attacking you, and you have unlimited ammo to fight them. I found this was a good choice, as it could be a slightly easier game to design, but also have possible future adaptations to make it more interesting and more fun in the future. To keep the game similar in theme to the Portal games, I decided to make use of the colour schemes from that game. It would make it look like a test chamber and keep it more of an industrial feeling. To allow a more simple game, I decided to go with more of a 8-bit character in a rough style of what a stickman would look like from the top view, and it would allow for very basic character motion and movability around the game. It was also designed to look very similar to the main character of the game, Shell. Shown here are the resources used in the game. It shows the two audio tracks, which are the shooting and background VFX, as you can hear probably behind me. The time map that I based the background off to make it look like the test chamber, as well as all the sprites for the character as well as the enemies. When researching making the game, it was essential that I replayed through Portal 2 as well as the original Portal to make sure I understood the entire aesthetic and feel of the rooms. But when it comes to researching for my code, one place I did a lot other than Moodle was making use of parallel reality. It showed different types of games and how to make them, as well as the different aspects of it, such as the sound effects, enemies firing. However, when it came to the audio, as there was a massive issue about trying to get that sorted, I made use of this tutorial here, which showed me how to run the mixer and audio to make sure everything was working as it should do, and as shown in the final game, the audio works correctly now. However, it is different to what he has specified here. Shown here is the class structure of my game. It shows the classes, the bullet manager, enemy, font render, which is used for score, game loop, player, sound, and the tile map. In it initializes the main surface textures as well as the variables. In the process input, it spawns more as well as checks to make sure the timing's correct. In update, it constantly adds the direction that they're going in to keep them going. However, if they are off the screen, it will then delete them. In draw, that's bad error. In draw, it constantly makes new ones to be visible on the screen, otherwise they would just be invisible objects. And in clean, it will remove the texture so no more can. There weren't many problems when making the bullet manager class, mainly when it came to processing input between the two classes. That was a main problem. I mainly tested that making use of breakpoints to make sure the correct values were passed in at the right times. So, the strengths of this are the fact that it is extremely efficient on memory, as once one is spawned, that one will also get deleted. So it's a constant cycle where if left long enough, every single one will be deleted and a minimal amount of space in memory. The weakness is the fact that that memory can also stack up a lot, so if the timer is set low enough, thousands can be spawned, and that's very efficient as it will fill up memory very quickly. This is the enemy class. It defines the renderer, the window width, and the bullet manager here. It initializes the surface of the turret to make it visible in the future. It also sets a texture, free surfaces it, and makes sure the font render is initialized. It also makes sure that the enemies are always at 5. In update, it will randomize the time to make a random seed based off it. It will create random enemy in the update, it makes a random seed making use of SRAND. It sets the size of the enemies to the previous enemies to allow for a comparison later. It then checks for every enemy, as well as every bullet, to make sure that none of them are overlapping. If they are, it will remove them and erase them from memory. However, if it then sets the new size of that array to be the current one. If it's 0, it will spawn more. If the previous enemies are lower by 1 than the current enemies, it will add 15 to the score and add another enemy to the scene. If the score is 50, every time the UI is updated, it increases score by 15 and then renders it. In render, it then makes sure that all of the enemies are shown and visible on the screen, and also in the clean, it will destroy the textures. One of the main strengths of this is the fact that it's very efficient, similar to with the bullet manager in memory. It will make sure everything is clean at the end, as well as little memory is used as possible. One of the main problems and weaknesses is the fact that it has quite a high big O notation. I believe it's n squared, as it makes use of a double for loop, which is good for what it is. However, it makes a lot of loops if the size of it gets extremely big. Game loop function is where all of the heavy lifting for the game is. It initializes all the variables as well as all of the separate classes to make sure they're currently initialized and in audio. It makes the audio load and sets the audio to the background music as well as the shots. It handles input by watching for the scan codes. Escape is shown. It will then clean and get rid of everything. It will handle input for the movement, and it will handle the enemy spawning, as well as the movement of bullets. It then renders everything, so all of the tire maps, players, enemies, bullets, as well as general renderer. It will then remove on call clean. It will clean everything and destroy everything to make sure nothing is left in memory. While being kept alive, the game will check for each of the key states and all of the inputs to change it. If certain buttons are pressed, it will then play background music, stop it, pause it. If space to shoot is pressed, it will play music and then process the input. It will then set to false if anything. Handling the processing elsewhere in the code is very effective, as it is freeing up space in its own self to only render what it needs to, as well as giving as little memory to each of the parent classes as possible, which makes it a major strength. There isn't many weaknesses to this other than the fact that it has to include every single one of the classes to make sure everything is loading correct. The font renderer is a small function made use of by other functions, where it will load a certain font, it will then render what is sent in. In this case, it is rendering score on the screen to display what it is. The tilemap class sets the background for the game, making use of the SDL image. This makes use of the map array here, which is a 2D array, which makes use of the previously made tilemap made up of all of the different textures from the Portal 2 rooms. This is then rendered in this area, in this nested for loop, and goes through one by one, making sure each of the ones specified are also rendered in game.